Everyone, my name is Lucia, and for this lightning seminar, I'm going to talk about the early COVID-19 antibody test in the context of Bayes' theorem and Bayesian updating. Let's start with a case study. So the first confirmed COVID case in New York City was on March 1st, 2020. And in just that first month, cases exploded. And by March 31st, the city had over 75,000 cases and over 1,900 deaths. The first antibody test was approved by the FDA in early April with a sensitivity of 87.5% and a specificity of 97.5%. As with all tests, this one was imperfect, and its accuracy depended on more than just its sensitivity and specificity. It also depended on external variables, in particular, the overall prevalence of the disease in the community. To understand this, let's take a look at Bayes' theorem. So we'll quickly go over the equation here so we can contextualize each component of the theorem in terms of the COVID antibody test. So Bayes' theorem, as we know, is a powerful tool for probability and statistics that describes the probability of an event based on prior knowledge of conditions related to the event. So the outcome we're looking for is called the posterior probability, and that's the probability of some A given some B. And the posterior is calculated as a ratio of the probability of B given A, known as the likelihood, and the marginal probability of B, or the marginalization. But the most important part is the extra term in the numerator here, the marginal probability of A, which is known as the prior. And this prior term is the key to Bayesian updating, and it's the reason that we can use Bayes' theorem to incorporate new evidence into our estimate to make the best possible inference. So with the antibody test, one of the main things that epidemiologists need to know is the probability that a positive test truly means that someone actually has antibodies, because this is important for contact tracing and for things like setting up plasma donation. So let's use that, the true positive rate, as our posterior. This is calculated by the probability of a positive test given the presence of antibodies times the probability that the individual taking the test has antibodies divided by the total probability of getting back a positive test. So here are the stats from April 2020 in New York City. At this point, the only prior knowledge that was even available was the overall prevalence of COVID in the community, which at the time was around 10%. You'll notice that the posterior of a true positive is 79.5%, which is okay, but it's quite a bit lower than the raw sensitivity of the test at 87.5%. And this is partially because the prior was so low, which brought down the probability of a true positive. Luckily, there are ways to improve these odds by using evidence to improve the prior and thus improve the posterior. The process of repeatedly going from the prior to the posterior is known as Bayesian updating. So at first, the best estimate of the probability that any individual had antibodies was just the overall prevalence of COVID in the city. But by incorporating more information about the individual into the prior, the posterior could be updated to better reflect the probability of a true positive. And one example of this being done in practice is from an international group of researchers who built an algorithm to incorporate questionnaire data into antibody test results. And I've linked their study in the description if anyone wants to take it out. So in their study, each subject that was given an antibody test also filled out a simple questionnaire describing things like their symptoms, their household, and whether they'd been going to work every day. The algorithm used an iterative method to take in this contextual information and propagate the uncertainty through their model. And with this method, they were able to significantly improve the posterior probability of both a true positive and a true negative test result. I think Harvard epidemiologist Mark Lipsitch puts it perfectly. In rough terms, Bayesian reasoning is a principled way to integrate what you previously thought with what you've learned and come to a conclusion that incorporates them both, giving them appropriate weights. And in the case of the COVID-19 antibody test, particularly in areas with new and explosive outbreaks where resources are limited and test accuracy is crucial, understanding and leveraging Bayes' theorem really is a matter of life and death. Thanks.